Ladies and gentlemen, boys and girls, welcome to another video. Please hit the like button, hit the subscribe button, and hit the notification bell so you will be updated on all my future content. So this video is going to focus on identifying fractions from the visual models. So we have our first visual model here, and I'm going to show you how to identify which fraction it represents. So fractions represent a parts to whole relationship. So when we're thinking of the whole, we're thinking of the total amount of parts. So the denominator, aka the bottom number, in the fraction represents the total amount of parts within the square. So to determine the denominator, I'm just going to count all of the boxes, whether they're shaded or unshaded. I'm going to count all of them. 1, 2, 3, 4. So this fraction model has 4 equal parts. 4 is our denominator. 4 is the total amount of parts that it has. Now, I'm going to count how many shaded boxes there are. There's just one, so there's one shaded box. So 4 total boxes, and one of them is shaded. So the fraction of shaded boxes equals 1/4. Alright, next example. Now these fraction models are supposed to represent equal parts. Sometimes they're not drawn exactly to scale. They might not always look completely equal, but they are supposed to represent equal parts. Keep that in mind. Alright, so now identifying the fraction that this model represents. To determine the denominator, we count the total number of boxes. 1, 2, 3, 4, 5, 6. So 6 is our denominator. Now, to determine the fraction of the boxes that are shaded, we're going to count the number of shaded boxes. 1, 2, 3. So the fraction that this visual model represents is 3/6. Alright, next example. So now we want to determine what fraction this model represents. So to determine the denominator, we count the total number of boxes. So we're counting all the boxes, whether they're shaded or not, to find the denominator. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is our denominator. To find our numerator, we have to count the number of boxes that are shaded. 1, 2, 3. So 3 of the 8 boxes are shaded. The fraction that this model represents is 3/8. Shout out to everybody tuning in. Please hit the like button. It really helps the algorithm. Alright, next fraction model. So determining the fraction this model represents. So the denominator represents the total amount of boxes, and the numerator represents the number of boxes that are shaded. So we have 1, 2, 3, 4, 5, 6, 7, 8 total boxes. 8's our denominator. To find the fraction of boxes shaded, we simply have to count the number of boxes that are shaded. 1, 2, 3, 4, 5. So this fraction model represents the fraction 5/8. Alright, next example. So determining the fraction that this model represents. So we have 1, 2, 3, 4, 5, 6, 7, 8. So the denominator in this fraction model will be 8. How many boxes are shaded? 1, 2, 3, 4, 5, 6, 7. 7 of the 8 boxes are shaded, so this fraction model represents the fraction 7/8. Alright, gonna do a completely new model, new visual model with a new numerator and new denominators. Shout out to everybody tuning in. Please remember to hit the like button. It really helps the algorithm. I appreciate you all being here. So now determining what fraction this model represents. So again, our denominator is the total number of boxes. Our numerator is the number of boxes that are shaded. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 total boxes. So our denominator is 15. Now we have to count the number of boxes that are shaded. 1, 2, 3, 4, 5, 6, 7. 7 of the 15 boxes are shaded. So the fraction that this model represents is 7/15. Alright, that is my video for today. Thank you so much for tuning in. Leave a comment. Let me know what you thought of the video. And if there is an area of math or reading that you're having difficulty with, put that in the comments, and I will do a future video on that skill. Until next time, this is Mr. Camilleri, signing off.